In this video, we are going to figure out how to use the solubility rules to determine if a precipitate will form, to determine whether a substance will be soluble or insoluble, and in the context of a chemical reaction, whether or not it will be a precipitate. First thing you need to understand is the solubility of common ionic compounds in water. I usually refer to this as the solubility rules. Notice that the solubility rules, pretty much everything in here has a negative charge. So it's all organized by anion. Remember, in a chemical formula, the anion is the negative ion will always be written second. So say NaI, the I is negative, the Na is positive. Or in KClO3, the ClO3 is negative, the K is positive. So essentially we're always going to be looking at the end of the compound to determine what the reaction, whether or not the substance will be soluble. Okay, so first off you need to understand the top half. So for the moment we're going to completely ignore the bottom half. We're just looking at the top. And in the top half we've got soluble compounds. These compounds are typically soluble, which means they will not form precipitate unless they're one of the exceptions. So that means that every compound with nitrate, every single one will be soluble because there are no exceptions. But if you have a compound with sulfate, usually it will be soluble. But if it's with strontium, barium, lead, or mercury, it will not be. So that means NaNO3 is soluble, and AlNO3 is soluble because these are both with nitrate. But say, let's see, K2SO4 will be soluble, but BaSO4 will not be, because one of them is with potassium, which is not an exception, and one of them is with barium, which is an exception. Alright, for the bottom half of the chart, so for the moment we're going to completely ignore the top half of the chart. For the bottom half of the chart, we're looking at things that are typically insoluble. So unless it's an exception, this thing will always form a precipitate or will not be soluble. Notice that every single one of them has compounds of NH4+ as an exception, which means that if it's ever with NH4+, it will always be soluble. And notice that every single one of them has alkali metal cations as an exception. Remember, alkali metal cations are group 1. So if anything is ever with group 1, it will always be soluble. So for example, let's say NaOH. So NaOH, Na is from group 1, which means it will be soluble even though hydroxides are typically insoluble. If you had, say, MgOH2, that would be insoluble because hydroxides are typically insoluble, and Mg is not in group 1, it's in group 2. If you had something like BaOH2, this will be insoluble because Ba is a specified exception to OH being insoluble. So this would be soluble, insoluble, and soluble. Alright, so remember that group 1 is anybody in group 1. So if you ever see any of these, or NH4+, and notice that NH4+ is also listed up here, it will always be soluble no matter what. Okay, so let's try a couple of examples and see what happens. Alright, the first example on your notes is LiCl. Remember that we're going to be looking at the ending ion, Cl, and I see Cl on the chart right there. And it says that Cl is normally soluble unless it's with silver, mercury, or lead. So, since lithium is not silver, mercury, or lead, we're going to call this soluble. That means it will not form a precipitate. The next one we have is ZnOH2. Again, we're starting with looking at OH. So OH is down here. This is generally insoluble. And let's see. Zn is not alkali metal. Zn is not NH4, Zn is not CaSRBa, which means that this would be insoluble. Okay, let's talk about Cu2S. Again, we're going to start with the S, the ending thing, and S is right there. Let's see, copper is not alkali metal, it's not an H4, it's not any of these, So since sulfides are generally insoluble, this will be insoluble. And KClO3. Okay, again, ClO3, let's see, I see it right there. That's generally soluble. There are no exceptions, which means it is always soluble. Alright, let's try a couple more. Okay, here we have AgNO3. Starting with NO3, let's look at NO3. There it is. That's generally soluble, and there are no exceptions, which means it will always be soluble no matter what the cation is. Okay, the next one is FeOH3. OH, that's generally insoluble. Fe is not any of these guys. It's not an alkali metal or NH4, so insoluble. Alright, let's get that out of here, and let's look at the next two. The next two we have our NaNO3, so NO3 is right there. Soluble, no exceptions. And C2H3O2, remember that's acetate. That's up there. Soluble, no exceptions. For the next set, I want you to look at the substances first and try to figure out on your own whether or not they're soluble before you let me give you the answers. I'll put them up on the screen. You can see PbI2, ZnSO4, NH42SO4, and CAS. Go ahead and try and figure out if these are soluble or insoluble, and I'll give you a second to pause right here. Alright, now that you've had a chance to look, let's go through them. PbI2, I is generally soluble, except that Pb is an exception, which means for PbI2, this will be insoluble. Alright, ZnSO4. SO4s are typically soluble. Zinc is not an exception, which means soluble. Okay. For NH42SO4, sulfates are typically soluble. Ammonium is not an exception, which will make it soluble. And we got CAS. CAS. Okay, well, S is down here, which is usually insoluble, but calcium is an exception, which means for calcium sulfate, it will be soluble. Alright. For these next four, think about it as, will it form a precipitate or will it not? So I'll give you a chance to pause here and think about precipitate or no precipitate. Alright, now that you've had a chance to look at them, let's look at these and talk about precipitate or no precipitate. If it is soluble, that means that it will completely dissolve, which means it will not form a precipitate. If it is insoluble, it will not dissolve, which means it will be a precipitate. So, starting with KOH, KOH would generally be insoluble, except for potassium is alkali metal, which means it will be soluble, which means no precipitate. Alright, PbSO4. Let's go with sulfates are usually soluble, except with Pb, which means it will be insoluble, which means it will form a precipitate. Okay, my next one is HgNO3. Nitrates are typically soluble, no exceptions, which means no precipitate. And my last one is K3PO4. Phosphates are here in the insoluble section, except that K is an alkali metal cation, which means that it will be soluble, that is, no precipitate will form. Alright, that's all for now. Thanks! The last thing we have to do is look at a chemical reaction and determine whether or not there's a precipitate. So, these are three examples that you have on your notes. We have K2SO4 plus BaCl2. Remember, in a double displacement reaction, we will make BaSO4 plus KCl. Ba is plus 2, SO4 is minus 2, which means those charges balance. K is plus, Cl is minus, those charges balance. To get the entire equation balanced, we need a 2, run the KCl. So now we're going to look at those two products and determine if there's a precipitate. So, let's start with SO4. Sulfates are generally in the soluble column, but barium is an exception. It's insoluble, so this thing will form a precipitate. We have Cl-. Cls are generally in the soluble column, and K is not an exception, so this will not form a precipitate. The next one is NaNO3 plus KCl. So here we will have NaCl plus KNO3. The charges are plus and minus and plus and minus. Remember, I did carry this 3 over to the other side because that's part of the identity of nitrate. Okay, so soluble or insoluble. Chlorides are generally soluble. Sodium is not an exception, so this will not form a precipitate. Nitrates are generally soluble. Potassium is not an exception, so this is not a precipitate. In other words, there will actually be no reaction happening here at all, because both of these things will completely dissolve. Alright, last one we have is MgBr2 plus LiOH. We'll make MgOH and LiBr. Let's look at the charges. Mg is plus 2, OH is minus, which means this will have to be MgOH2. Li is plus, Br is minus. That's balanced, but overall we'll need 2's there to get a big balanced equation. Okay, solubility. Hydroxides are generally insoluble. Magnesium is not an exception, so this is an insoluble compound, which means it's a precipitate. Bromides are usually soluble. Lithium is not an exception, which means this is a soluble compound, not a precipitate. Okay, well, I hope you now can understand how to look at products of a reaction and determine whether or not a precipitate will form. Thank you very much for watching.